Hello, welcome back. This is Craig, and we got some boxes over on the bench. We're going to open them up, see what's in them, but I'll give you a preview. About 3 weeks ago, I was reading Electronics Lab here, and they had an article about a thing called a ClearCore, and it's entitled ClearCore New $99 4-Axis Motion I/O Controller. If we scroll down here a little bit more, it's from a company called Teknic. Now, Teknic came on my radar about 3 years ago. I was watching NYCCNC. John Sanders over there gave a demonstration of a Teknic ClearPath motor. I think he ended up using a servo motor, and it is a closed loop high performance for CNC or machine control. And that was a really impressive demonstration. I'll go ahead and have that link in the show notes. But I just hopped online and I looked through this thing. If we come down here, let me see here. So I think we're going to go over to, oh wait, here we go. Thing that's, it also comes with fast, it has a free Arduino wrapper for it, so you can create your applications right in Arduino, which is good. It makes things a lot simpler. And then they also have a ST++ library that's got 40 extensively commented examples. So it's got like an attractive thing. So I went ahead and ordered them. And then I went over to, I literally, just ordered them right then. So if we go over to Teknic, and we go down to, this is like we go over here to ClearCore. Let's look at this thing here. Okay, so here's a picture of it here. So it has these 4 connectors down here to go to your motors. There's no drivers in these things. It has a bunch of I/O pins. There's an Ethernet port up here, a USB connector, and 2 serial ports. It also has an XB socket inside, so you can run wireless communications and some kind of expansion I/O port. Why I wanted to get this? Here's a video that they came out with in December. Yeah, I'll have a link to this down in the show notes. The interesting thing about this is it runs a Cortex M4, so that has a math coprocessor in it, which will make it more efficient and do numerical calculations, which is exactly what your motion controller should do. The 2 serial ports over here run a UART or SPI. That's actually pretty cool. And there's +5 on the connector as well. So this is an RJ45. An RJ45, this Ethernet. Same as used for Ethernet. So you can wire up stuff and connect your external I/O with the Ethernet cable. You can put up to 64 more I/O points on these things here, which is pretty impressive. And then there's a header over here to expand out some additional I/O. Now these aren't proprietary connectors here. I think I have some of these actually. What I ended up doing is I ended up buying some of these. It's got a polycarbonate aluminum case. So the reason why this was attractive was, one, the price. Second was it was due 4-axis, and it has an enclosure that comes with it and Ethernet built in. So it's got a lot of things going for it. So I went ahead and ordered 3 of these. I just blindly said, let me have 3 of these. I think that's what's in this box over here. We'll show you those. And I ordered some of these connectors from DigiKey as well. So let's hop over to the bench. Here's some examples of small systems that are there. This video here, I ended up commenting on that video that I showed you there. It's an unattended bartender, and they use basically all the functionality that this thing can do. They implement a very sophisticated control system. I wrote a comment on here, and I almost immediately got back a reply from Teknic itself. which shows that they actually monitor their social media presence. There's not hardly anything out there about these ClearCore controllers. The comment I got back was from one of the tech support people. He's probably a field application engineer over there. And he said, just be aware. Now, this is after I ordered them. And they were already shipped. Be aware that there's not a G-code interpreter for this. And that's quite an undertaking to actually get that to work. Unfortunately, I've gone through and worked on somewhat of a port. I understand how the internals of grblHAL work. I've done that I worked on that for a PSOC 5. So I think I'm going to be pretty successful. Now, on the grblHAL side, this is too much talking. Let's just get over the bench and do our unboxing. All right, so here's what I got here. So this one is from Teknic itself. This is my DigiKey box, and I ended up getting a little bag of parts here. So we will open up this one first. It's pretty well packaged here. And I got 3 of these and a packing list. And if we look inside here, it's got foam. This is a double box thing. Now here's, oh man, this thing is great. Look at this thing here. Of course, we got crappy lighting. Man, let me zoom in on down here where the lighting is better. Okay, so here's the ClearCore. It's got some like a little bit of weight to it. There's an aluminum back here. It's got machined holes that are using these press-in threaded holes. And it also has mounting holes through the base here. And it turns out that they also sell as an accessory to this is a DIN rail mount that screws onto the back of this. You can mount it right on your DIN rail. Here's that I/O connector over here. Now this is just a straight 2 by, I don't know, 10 connector there. These guys here, it's a pretty common part. This probably, well, look at what I ended up ordering over here, but I know that these are Molex Minifits. This is a 2 by 8. Like I said before, this is Ethernet. Ethernet here, but this uses Ethernet cabling here. And it has one of these older USB connectors here. Now, why are they using this? Because this guy is reliable. If you think about, you know, a USB mini or a USB micro, this thing is ultimately interfacing with potentially like really old equipment. So it may not even be able to talk over USB 3 or USB-C. So this one's probably the most used connector, and it's a very reliable connection. You won't break it off by hot plugging it a bunch of times. So that's that, and I got 2 more. I got 2 more in the box here. So let's see what I got from DigiKey. I ended up ordering all those connectors, and I've used those Minifit connectors on several designs in the past, so I'm really well familiar with what they are. And I'm glad they decided to use those. Here's the 4-position header. What is this thing? What did I end up ordering? Okay, here's the 2 by 8 Molex parts. This has got multiple things in it. And then these are the 3-pinners right here. Looks like I got some resistors here. These Minifit connectors, let's open this guy up. These Minifit connectors are crimp-on guys, and they have a positive latch here. This thing will focus on me. It's a positive latch to keep it, you know, locked in to the connector. And these come on a reel. I bought a reel of these pins here. I brought a couple hundred of them because I got there's four on each times 8. That's what's that? 4 times 8 is just brained it, 32. And so anyway, I got a bunch of these connectors here. What else is in here? Oh yeah, there's multiple customers' orders are in this box. Okay, so let's look at the 3-pinners. So like I said, these ones, all these I/O connections around here, this is a pretty popular part. I think I ended up getting the ones that were recommended by Teknic to use for this, but there's a lot of clones of this particular guy. You can tell by it's got this little triangle key up here. You can see it there. Black on black's kind of crappy, but this guy's pretty popular here. Like I have a design that uses a bunch of green ones, but I went ahead and got what they recommended, which is the black one. And this one is just a screw terminal here. So that's good. So what we'll do is power this guy up and see what it does. You can hear this thing click. If it does, there we go. All right, so let's power this guy up. Okay, so I got my power over here. And now these things here, these are nice because all these digital I/O pins here, there's some analog ones up here as well. And if you do look at some of the documentation, one of these analog ones will do 4 to 20 milliamp loop, which is pretty common also for control loops in industrial environments. So you have I think it's +5 and ground and the signal itself on every connector. That is dang convenient there. Down here you got your power, and it's clearly labeled plus and ground and earth ground. So we will make sure we connect this up right. Ground is in the center. And I think that these guys here are let's see what happens here. Yeah, these ones come shipped from the factory with the little cage mechanism in here all the way open. That's good. So that one's in the center. A lot of times some manufacturers have it the other way, and you sit there and turn the screw and you don't know what's going on. All right, let's check our work. And of course I've screwed it up. I think I checked my work before I got there. I got the center one right. Okay, we quickly know that when my power supply would croak. Here we go. Check it one more time. Red to the plus. Red is plus over here. What do we set this up to over here? Guy's set on 20 volts. Well, let's see what happens. Wow, that guy fit in there really well. It won't come out either. Okay, good. Here we go. Oh, look at that. It's doing something. Wow, that's kind of cool. Let's hook up a USB and see what happens here. So I'm at the Teknic site here, and we're going to go to downloads, go to ClearCore. And like I said before, there's a full set of drawings here, and I think I'm logged in. If you don't see this, if these look, you may have to log in to see this kind of stuff here. We're going to come down here to software. So here's the ClearCore. This is the library that runs on the atmel development IDE, and then here's the wrapper for Arduino. So if you look at these sizes over here, it's 290 megabytes. So I did download that zip file, and I unzipped it, and it's a single exe. So the tools that they provide are for Windows, but we're running Linux today. So I'm sure if you're on Windows, you can just download this and it'll install everything you need. But we're not going to do that. But we are going to struggle through something else here. So we're going to come over to GitHub, go to Teknic again, and find that ClearCore. Not the library. This is the one that runs in the @mail IDE. We want that wrapper. So they have the wrapper. It's a repo on GitHub. That's good. Okay, so let's go ahead and start the. I'm going to run Docker to run my IDE, much like I've done in previous videos. So we'll go ahead and get that started here. All right. Default installs of Arduino only has the boards for the AVR processor family. So what we need is that. We need that URL. We need that. Let me see here. Where did our guy go here? Is it this one? Yeah. So here's the wrapper file, and if you kind of look down here, this is an Arduino board support. This is actually the ClearCore library. So plus the definition of the CPU in the ClearCore itself. So we need that JSON file. This is the file we need to tell the board manager to get this from. So you don't want to copy this URL up here because this URL really contains all this HTML stuff. We want to click on raw over here. Grab this guy out. Now I've done this for a lot of different processors, so this is pretty inherent to what I kind of understand how it works. So we're going to go back here in Arduino. We want to paste that URL right here. And then we want to come over to the board manager. And we're going to type in Teknic here. And then come up with anything. How about ClearCore? Now there it is. All right, so we're going to install this. Okay, well that's installed. So close that up. And under the board manager now, we should be able to see. So it has two families in here now. You have the AVR guys, and then you have a Teknic ClearCore shows up as a board. So we should be able to compile it. This sketch doesn't do anything. So we'll go over and we will try to upload this thing. And it doesn't look like it is working. All right, what else do we got to do here? Oh, we got to set the port to ACM0. Okay, let's try that. Oh, look, it worked. Our lights stopped blinking. All right, hey, something happened. It's always good. All right, so let's, we should have all the examples in here under their ClearCore. So if we come down here, yeah, right here, examples for the Teknic ClearCore. So here's the analog I/O, CCIO, ClearCore board status, Ethernet, I have a UDP hello world. What's this one? Some mode examples, digital I/O, SD card. Oh, I didn't show you that. This thing has an SD card on the side. Serial communications, step and direction, and XB. I didn't see a blink in here. Let's go open, let's go to sketch or examples, And under basics, we'll see the blink. Here's the blink sketch here. So I can make that font a little bit bigger though. Let me do that. Let's do this here. Let's make this. And I think after we set that, oh good, it's going to do it. Do it real time. Okay. So it's got LED built in. I don't know if that's defined. Let's go find out. So we need to come back over to our where we ran this thing. All right, this is running Arduino here, so I'm going to put that in the background. And then right here, look at all the directories here. Oh, under Arduino 15, packages, ClearCore. Oh, good. Okay, hardware, SAM 111. Cores. Is this us? Arduino. Here's all the source code for that. So let's LED built-in. They defined LED built-in as the ClearCore pin LED. Wow. Well, that's good. So it's defined as something. All right, so this one here is got a define in it. It defines it as something. So let's compile it and see if it's going to do something. And we'll run this here. I don't know what it's doing here. Oh, it's doing something. It doesn't look like it's working too well, though. Looks like I kind of did something over here. What did I do over here? Let's go ahead and save that as blink. Looks like my flasher died. Yeah, it's not too good. All right, let's compile it. I think I killed the whole. No, I didn't. Hold on. There was another window popped up over here. Okay, so it looks like my flasher died. Looks like the whole thing died. Oh, that's not good. Yeah, I did something here. Let me, wow, I really have screwed up something. All right, so it turns out I had to, like, start over again. Not start over again. I had to start Docker again and start the IDE after that failed upload. So let's now that port isn't showing up over here. The port is, my ACM0 isn't here. What's the, oh, we're back to this. But I read somewhere that if the firmware upload doesn't occur, if there's a failure in that, it kind of gets the microprocessor in a funky state. So I read that if you tap the reset button twice, it will reset all that stuff. So let's try that. It's over on the ClearCore. There's a reset hole right here, and I got my paper clip out here. We're just going to try this twice. Okay. Now we'll come back over here to this guy and try to run it, try to program it again. It's not looking good. So we'll come and check this again. Oh. Hey, I got it going. Oh, look at this. Dun, dun, dun. We have the blink running. I call that a success. All right, well, we're looking pretty good. We're looking pretty good. Let's try something else. All right, well, let's try the next example here. We come over here to examples. There is an Ethernet example. So this is the UDP Hello World. So it comes down here and it gets the Ethernet MAC set up, right? And here's our IP address. Oh, good way to get this added here. So we're going to do, let's pick a number here. 121, port 888. And we want that to be false, I believe, because we want to set the IP address. And let's save this one. We will compile it. All right. Let me go plug in that ClearCore with the old Ethernet, which is right here. Okay, the activity lights are going on the guy here. Is just the example here. So I got the Ethernet plugged in. And we compiled it, so let's try to program it. Hope we don't have any problems with this programmer again. It looks like it's running BOSAC. Oh, there we go. Oh, look at, oh, there's something else in here. This one actually is a serial print. When we open that 9600 baud. Let's come over here and we will run a serial monitor. Let me bring this over here. Serial monitor at 9600 baud. So what do we want to do? We want to, what do we want to do? I think it's already gone past that point where it's printing something. Well, that's okay, I guess. All right, so let's go back over my host, and what's that IP address? 121. So we're going to use Netcat. Okay, Netcat's short. NC is short for Netcat, and we're going to do. How do we do the 192? I think it's a U. Is it a U? Let's see. We want to look for our UDP. Where's UDP here? I think it's a U. Yeah, UDP mode. So we're going to do NC minus U 192 168 0.121 port 888. 4 8s. All right, this is the big test. Where'd my console window go? Here we go. This is a test. Aha! Would you look at that? Okay. This is the test came back and this thing said hello world over here. Oh, well, how cool is that? So let's do something a little differently. Let's echo back. Where's that hello world thing? Where did I do that? Here it is. Send hello world. It's right here. Now the packet received was brought in on packet received and bytes read. All right, let's do this. You think it's going to compile? Well, it compiled. That's a good thing. It's like I can kind of know what I'm doing here. Uh-oh. Device not found. Oh, I got the serial port opened. Let me close that guy up. Now what? Uploading. Oh, we got another error. Now what's going on? Our port died here. Let's save the blink. Let's quit out of that. I'm going to run this again. And it pops up over here. So here's our UDP thing. So we have a serial port now? We don't. All right. Oh, something happened. Whatever we did, we're back to this again. So what did we do? We had to, let's power cycle it first. Well, I don't know what it's doing there. It might be running UDP again. Let's try to flash it again over here. No, found it that time. It's like power cycling found it. Oh, it might be going. Okay, that worked. Bring up my other window here. Connect to it again. This is a test. Aha! Right there. And if we bring up that serial port, the monitor over here, let's type in that command again here, if I can get my windows going. This is test 2. There we go. This is test 2. Okay. So we did an unboxing, and I set up an Arduino environment. And I have to confess that I did set up the Arduino environment before I actually got the boards or the ClearCores in here, so I kind of knew what was going on there. But basically, you set it up, you add the board package from their GitHub repository, you can install it, and it finds it on the Linux side. And that serial port that comes up when we first booted these guys up, it came up as a disk drive, mass storage device, and also a serial port. We couldn't. I think we couldn't talk to it with a serial connection because it was running a bootloader. And we verified that by actually trying to compile Blink and put it over there, and which we were able to do. Now, like I said before, I've had problems with this particular type of mechanism to upload firmware when the reason why the first Arduino boards were very reliable is that they relied on a FTDI 232 part, which presented itself as a USB serial port. And when the operating system opens the serial port, it effectively sends over the USB. It says, go ahead and drop DTR, or this other thing called RTS. And all those original hardware designs for Arduino, that line was actually wired into the CPU. Because of that, you got a really clean reset on the CPU. So the bootloader would toggle the reset line on the CPU, which would kick it back into the bootloader, and then it would do an upload. That was rock solid. Now this particular part, as well as I've had this exact same problem on the STM32s, where the we're using the serial port in the bootloader, the internal serial port, doesn't quite get reset correctly in order for the uploading process to actually take place correctly. And we saw that here. So I had to try a couple of different things and I got it to work. But from a serious development standpoint, that's not how I want to work, because I don't want to monkey around every time that the upload fails. Plus, it takes a long time to do that. So they do offer a different option, because there's a this, ARM Cortex processors can be programmed over serial wire debug, which is a 2-wire interface. So we're going to go back over here, show you some other things on this product page. So back on the ClearCore product page, if you scroll down here, right here, powerful debugging. So this is something I didn't order right off the top, right to the start. So this is the apt-get ICE for ARM, and it has this this cable over here, and this cable over here is called a what is this thing called? This is a special kind of cable. I've used these before. Let's look up this serial number here. I actually have this footprint on one of my designs. Tag Connect. Okay. So Tag Connect connector is push pins on the. So you could lay down a very small footprint on your board, and it'll make all the necessary connections. So this one here doesn't have the attachment feet on it. The one that you buy here, if you zoom in on this guy, this one here has the attachment feet. So what you can do, I guess, in the ClearCore is, it's kind of outlines this in the manual. You pop the top off, connect this up, and connect it to the debugger. And then the Arduino development environment, as well as the apt-get development environment, will see this as a legitimate programmer, and then you can flash it right over as SWD, which always gets a clean reset. And I can show you something else over here. So when I'm developing for STM32, I don't really ever use the internal USB serial port. So when I'm doing all my STM32 development, this is a blue pill board, and then you can get these programmers. These are like clone. What are these things? ST links. And so you just need 3 wires out of here plugged into this board. These things are pretty rock solid. And then I use one of these. This has got an FTDI 232 part on it, so USB comes over here. So I use this particular STM32 has got 2 serial ports. So when I'm running the Arduino development environment, I can access those ports a lot better using this thing here than the internal USB connector over here. So I suspect it's the same kind of issue, because both of these, this is a core, this is an M3, and that's an M4. So I anticipate when this when the ICE debugger comes in, I'm going to connect up to this guy here directly and not have to deal with this USB firmware update. What about the issue with the not having a G-code interpreter? I've been following this other project called grblHAL. All right, so this is grblHAL over here, and it says grblHAL has been moved to a new home. All right, so what grblHAL is different. So Gerbil was originally written for an apt-get ATmega 328, and it's highly optimized for the 8-bit core that's in an AVR processor. And a lot of people have taken that core and ported it to, they ported it to Cortexes, and they ported it to TI parts, and they ported it to ESP32, or ESP32, 8266. It's just, there's a lot of ports going on. Well, if there's any change in the core of Arduino, those ports now have to go through the rigorous process of intertwining their port code in with the grblHAL. What grblHAL project is it adds an abstraction layer between grblHAL itself and the hardware, and it should make doing grblHAL updates a lot easier because the abstraction layer won't change at all. So this is a project here. It's got these ports for all these different processors. These are TI parts. Here's STM32F4, M3, M1. Those blue pill boards, or any of the F103 parts. SAMD21, SAM3. Here's the Raspberry Pi they call that thing? Pico. This Raspberry Pi Pico 2040. It's a PSOC 5. These are TI MSP parts. Here's another processor. There it is. Here's the core. So I contacted the author of the primary guy that came up with this, and I told him I'm interested in doing this. His grblHAL has been available for quite some time, and I've been kind of following it along for about a year now. And when he ported, he took all that code and stuck it over into being into these separate individual GitHub projects. So what I'm going to try to do next on the ClearCore is create a port for the ClearCore that runs his grblHAL code, which is capable of doing up to 6-axis on an M4. So this is what my next big project is on the CNC side. So if you've made it this far, I'd like to thank you for that. So what we did here was we did an unboxing. I got 3 of these. We got the connectors for it. We powered it up. We created a Docker container with the Arduino development environment. I downloaded their wrapper. Was able to program I was very able to program Blink on it, and I was also able to do UDP. So I know that at least those work. So I'm going to go through in future videos here, after I get this programmer and have a little bit more reliable uploading process, we're going to explore the other things about the ClearCore and kind of look at all the little ports on it, what you can actually do with it in terms of digital I/O, analog, the H bridges to run regular motors, and as well as controlling a Teknic ClearPath stepper motor. Okay, well that's it for now. Thanks for watching.